Okay, welcome back everyone to Grockit's OGTV. Grockit, like it says there in the corner, we're doing the GMAT edition where we go through the Graduate Management Admissions Test, the official guide to the test, the 12th edition, over there. Oh, that's not supposed to be a frowny face. You're supposed to be happy that you're studying. My name's Jim Jacobson. I'll be your teacher today. Last time we were finishing up the problem-solving section of the quantitative half of the book. Well, we won't finish it up today, but we're getting close. We left off on page 177. We finished with question 177, and so we're moving on to question 178 today. So go ahead and open your books to page 177 while I start to get the rest of this stuff down on electronic paper. Whoops, I already did it wrong. So it is page 177, question 178. So we have 68, 69, 74, 79, and 84. So the table above shows the number of students in 3 clubs at McAuliffe School. Although no student is in all 3 clubs, 10 students are in both chess and drama, 5 students are in both chess and math, and 6 students are in both drama and math. How many different students are in the 3 clubs? So it was something like this. So we're given some information in chart form, and then we're given some information in the actual question stem. I'm a big fan of Venn diagrams, you know, those things, those overlapping circles. Now in this case, normally we will have, something that looks like the logo of a credit card. In this particular case, we have 3 clubs, so we are actually going to need 3 circles. Okay, so, and we're given some of this information, and so let's call this guy chess, this guy drama, and we'll call that one math. We have 40 people total in the entire circle for chess. We have 30 people over here in the drama circle, and then we have 25 in the math. I didn't draw them in the circles because I'm using that space inside the circle to show the areas that are excluded. So for example, if I were to write a number here, that would not include numbers here, here, or here. That's just my own personal convention with drawing these things. You can do, whatever you want, basically, as long as it keeps you getting the right answer on the test. We also get some information within the passage. So we get 10 students are in both chess and drama. So that's 10 students in the overlap between circle C and circle D. We have 5 students in chess and math. And then we have 6 students in drama and math. And it says no students are in all 3, so we can write that in there. And so we just need to figure out how many students are in all 3 clubs. So the total number of students, basically. We can't use these numbers on the outside because these numbers include values that are double counted. So this math value includes 5 that are also in chess and 6 that are also in drama. But actually that gives away what our way of succeeding in this problem is. And so I'm going to write the information that we infer in a separate color here. If there are 25 total students in math, 5 of them are also in chess, 6 of them are also in drama, that leaves 11 that are just in math on its own because, 14, 14 plus 11, 14 plus 6 plus 5 gives us 25. We do the same thing for the other 2. For the chess club, 10 are also in drama, 5 are also in math, which means 15 are in something else. So 25 are not in something else, they are just in chess. Likewise, 10 and 6 are in something else for drama, so 14 are in just drama. And if we add up all of these numbers within the individual little sectors, or not even sectors, just these little subsections of the circle, we add all of these numbers together, we should actually get the total number of students. So we add 25 and 14 and 14 and 10 and 5 and 6. Add all those numbers together. So, You can pair it up however you want. I'm one of these people who likes to get things to even tens. So that's 30, and here's another 20. And then we have 24 left. So 30 and 20 and 24 gives us 74. Answer choice C. Last one on page 177 is question 179. We have some fractions in our answer choices: 3/4, 8/9, 18/19, 23/24, and I can't answer. So this type of question is relatively rare and really just tests your, it certainly is testing concepts as well as computation. Whenever they give you the option, it cannot be determined from the information given. So the ratio of two quantities is 3:4. If each of the quantities is increased by 5, what is the ratio of these two new quantities? So the ratio is 3:4. This is actually a fundamental lesson of the nature of ratios. That is, basically, that the real numbers that are behind the ratio can be something very different. Let's just say it's 3/4. If we add each of the quantities, if we increase each by 5, so it would actually, there's no equal sign, it would be 3 plus 5 over 4 plus 5, which gives us 8/9. Answer choice B. What happens if it's a multiple, though, of this same ratio? If we start off with 6/10, 6 plus 5 over, what? 6/10, 6/8. So that's double, and then let's say triple would be 9/12. 6 plus 5 over 8 plus 5, 9 plus 5 over 12 plus 5. So here we get 11/13. Here we get 14/17. And basically, if it isn't clear by now, I'll just outright say, when you have a ratio, adding flat numbers to the elements of the ratio leaves you with a ratio that you have no idea what the new ratio is, because you have definitely changed it. And I guess the one exception would have been if the ratio had been 5:5. Adding 5 to both elements would have been fine, but I don't know why the GMAT would test that. So obviously this guy here is a trap, because that's just assuming you added 5 to each. The original answer is assuming that you think that adding the same number to the numerator and the denominator leaves the ratio the same, when in fact it's multiplying the numerator and the denominator by the same thing that leaves it the same. These other two ones, I have no idea where they got them from. But, so this one, there's almost no math that we needed to do, but if you wanted to test out the theory, that's what this stuff is for. You simply cannot determine from the information given, without knowing the original numbers that are in the ratio. Adding numbers to a ratio is nonsense. Answer choice E. On to 178, number 180. So we have 70, 40, 20, 10, and I can't say. So same sort of thing, we're testing some concepts and some math. Again, be very, very careful whenever you see one of these ones where it's, it cannot be determined from the information given. It doesn't mean that that's the answer, of course, but know that there may be some kind of trick, that some sort of thing that they're testing about solvability in general. So if the average of x and y is 60 and the average of y and z is 80, what is the value of z minus x? So average of x and y is 60, so x plus y divided by 2, that's how you determine their average. That's 60. And we have y plus z, average of those two is 80. The question here is, in case it didn't jump out at you. The question is testing number of variables and number of equations. Remember, in order to, sort of a general rule is that for every variable you have, you will need an equation in order to solve for that variable, or to solve for all the variables. So if you have two variables, you will need two distinct equations to solve for those variables. In this one, we have three distinct variables, x, y, and z, and only two equations. And so that's where choice E is coming from, that you cannot determine from the information given. However, in this particular case, we are not actually solving for a variable. We are solving for a relationship between two variables, and that you can do with only two equations. First off, let's get rid of the fractions. So if we say x plus y equals 120 and y plus z equals 160, from here, remember we're trying to solve for z minus x. So we can actually just subtract this equation number 1 from equation number 2. So if we kind of rewrite this as y plus x equals 120 and subtract that whole thing, this is what's called the combination method of solving systems of equations. Y minus y is 0. Z minus x is z minus x. And 160 minus 120 is 40. The question was actually asking us for what z minus x equals, so answer choice B, 40, is our correct answer. So again, this was the big trap here. It is good to check, you know, especially when you have when you get the "it cannot be determined from the information given" in your answer choices. You know, one of the first things you should check in a question like this is, do you have enough equations for your variables? But do also double check whether it's a relationship or you know, a relationship between the variables or an actual variable that it's asking for. Okay, on to the next one. So 178, number 181. So 15/16, 7/8, 1/4, 1/8, and 1/16. So if half of the air in a tank is removed with each stroke of a vacuum pump, what fraction of the original amount of air has been removed after 4 strokes? So 4 cycles of this vacuum pump. So the first one removes half of the air. So only half of the air is left, and each stroke removes one half. So if we have 1/2 of the air left and it removes 1/2, it's 1/2 times 1/2. Now there is only 1/2 of 1/2. Come on, give me the dot. There we go. Now there's only 1/2 of 1/2 of the air left on the third stroke, and it removes 1/2. On the final stroke, it removes half of that value. So we have to add together the fractions. So each of these represents what fraction of the total tank the vacuum pump has removed. So we have 1/2 plus 1/4 plus 1/8 plus 1/16. And we convert it all into sixteenths, so this is 8/16 plus 4/16 plus 2/16 plus 1/16. 8 plus 4 is 12. 12 and another 3 gives us 15/16. Answer choice A. You might have, if you're more of a visual person, you can imagine a tank. They don't usually make square tanks, but it's easier to divide it into quarters. So the first stroke removes half. The second removes half of that. The third removes half of that, and then the fourth stroke removes half of that. So this is all that's left, and if you're kind of figuring out how this is divided, you can kind of see that it ends up being 1/16 because then it ends up being a 4x4 square. You're not always going to be able to do it visually, but again, the GMAT is kind of a by any means necessary. Oh, I shouldn't say by any means necessary, cheating is naughty, but however you can correctly, appropriately, and quickly arrive at the correct answer, that's the way to go. Right. Number 182. So 178, number 182. So we have 181, 165, 121, 99, and 44. So if the two-digit integers m and n are positive and have the same digits, but in reverse order, which of the following cannot be the sum of m and n? So when you get digit questions like this, it is often good to just create individual numbers for the place values. So we can just say t equals the tens digit. We can say u equals the units digit. We could call it the ones digit, but 0 is the worst. O is the worst variable to use because it looks like 0. Good story. Anyway, tens and units. So if that's the case, the actual value of m would be 10 times the tens digit and just u times the units digit. Since the digits on n are reversed, we would have n equals 10 times that units digit plus, 1 times the tens digit. So then we need to figure out the sum of m and n. So we can just add them together. So m plus n equals 10t plus u plus 10u plus t. 10t plus 1 more t equals 11t. 1u plus 10 more u equals 11u. M plus n. So m plus n then equals 11 times the sum of the tens digit and the units digit. So no matter what, m plus n is going to be a multiple of 11, no matter what tens and units digit we choose. So whatever the correct answer choice is, it needs to, the correct answer choice needs to not be a multiple of 11. Because the question is asking which one cannot be the sum of m and n. So right away we can cross off these two guys. 121 is 11 times 11. So we're left between 165 and 181. Let's just pick one. We'll do 165 divided by 11. 1. Maybe you could have done that in your head. I'm not that smart. So 5 times 11. 55. Okay, so this one is a multiple of 11, leaving only answer choice A, 181, as being not a multiple of 11, and therefore not a possible sum of m plus n. Okay. 178, number 183. So 2/3, 1, 1 1/3, 1 3/5, and 3. So car X and car Y traveled the same 80-mile route. If car X took 2 hours and car Y traveled at an average speed that was 50% faster than the average speed of car X, how many hours did it take car Y to travel the route? Or route, depending on where you grew up. So one formula that's important to remember on the GMAT, one of many. There's lots of important formulas, but this one's pretty big. Average speed, that's a V for average. Average speed equals total distance over total time. So we have car X, which did 80 miles total distance, total time in 2 hours, so its average speed was 40. Car Y, we don't actually know how fast it went, or do we? The question actually tells us that it was 50% faster. A 50% increase on 40, 50% of 40 is 20, so we add 20 onto 40. Car Y must have been going 60, which is 50% faster. Okay, so car Y went, if car Y is going 60 miles every 1 hour, how long did it take it to go 80 miles? We'll call that X. So cross multiply, 60x equals 80, and X equals 1 and 1/3. You could have also said, what do I need to multiply, looking at this original fraction here, or equation, what do I need to multiply 60 times to get 80? 1/3 of 60 is 20, so we would need to add 20 on, so it's 1 1/3. 80 is 1 1/3 of 60. Gives us answer choice C. All right. 178, 184. 11, 15 3/4, 22, 23, 25 3/10. So if the average of the four numbers k, 2k plus 3, 3k minus 5, and 5k plus 1 is 63, what is the value of k? Straightforward. You just have to remember the average formula. That's a V, really. Average equals the sum of the numbers divided by the number of numbers. So we need to figure out the sum. We have k plus 2k plus 3 plus 3k minus 5 plus 5k plus 1. And we have four numbers total. That was k, 2k plus 3, 3k minus 5, 5k plus 1. Four numbers divided by 4, that equals 63. So we multiply both sides by 4 and then kind of add up all of our k's and constants here. So 5, 6, 7, 8, 9, 10, 11. We have 11 k's. Plus 3 plus 1 is 4, minus 5 gives us minus 1. 11k minus 1 equals 63 times 4, which equals 252. So 11k equals 253. I can't do that in my head. 253 by 11, so 22, 33. Now, obviously, when you get here and see it's a multiple of 11, you don't necessarily have to do it the rest of the way. I'm doing it for your benefit. Anyway, so 11 goes into 253 23 times. K equals 23. Answer choice D. Uh, 178, number 185. So P over Q, PQ, 2P plus Q, 2 times P plus Q, and 3P over Q. So if P is an even integer and Q is an odd integer, which of the following must be an odd integer? So is even, Q is odd. So there's really no figuring we can do before we get to the answer choices. We actually just have to examine them one by one. This one, it's absolutely essential to know some basic number properties, especially how even numbers behave when, well, how even and odd numbers behave. But in particular, we're looking for the one that must be an odd integer. Let's choose P over Q. Now, you can pick numbers or you can just kind of reason your way through. P divided by Q, an even number divided by an odd number. If P is a multiple of Q, so let's just say P is 6 and Q is 3, 6/3, that would equal 2, which would equal an even integer. Which rules out answer choice A. We're looking for the one that must be odd. On top of that, what if P is 2 and Q is 3? That doesn't even equal an integer. So, and we're looking for the answer that must be an odd integer. So answer choice A, you have let us down. Answer choice B, P times Q. One important thing that, again, if it were legal, you'd want to have tattooed on your arm, is that an even number times anything, well, an even number times any other number, even integer times any even integer will give you an even integer in the end. Even number times anything gives you even. So if P is even and Q is odd, it doesn't even matter whether Q is odd or even. Even times anything is even. So answer choice B is not the one. Because again, we're looking for the odd one. 2P plus Q, 2 times, so again this is even times anything is even, but then we have to add Q, which is odd. Even plus odd, just do 2 plus 3 in your head, gives you 5, which is odd. Even plus odd is always odd. So answer choice C is looking like our awesome answer choice, but we should double check to make sure that we're not missing something obvious. 2 times P plus Q, this is again even times anything. Gives us an even number, so it's not answer choice D, because 2 is an even number, so no matter what was in the parentheses here, it was going to be even. And once again, choice E, not only, so the numerator is going to be even, because P is even, so 3, you know, this has both the even times anything thing going for it. It also has the possibility of not even being an integer. Full right. Maybe not integer. So it's not answer choice E either. So the only one that must be odd is answer choice C, the one that looked attractive to us originally. On the real GMAT, especially if you're pressed for time, you could have just stopped after answer choice C, and if you felt pretty confident of your reasoning, and then saved yourself the time of going through the remaining 2 answer choices. All right. Last one on page 178, number 186. 3/4, 5/6, 11/12, 7/6, and 11/6. Drum X is 1/2 full of oil, and drum Y, which has twice the capacity of drum X, is 2/3 full of oil. If all of the oil in drum X is poured into drum Y, then drum Y will be filled to what fraction of its capacity? Just a little reasoning here. So drum X is half full. Drum Y. So drum Y has twice the capacity. So half of X would be 1/4 of drum Y's capacity. So drum Y is twice drum X. So 1/2 of X equals 1/4 of Y, because it's twice as big. So we just add these 2 fractions together. We have the original amount that y is full. Y is 2/3 full. And the amount in x amounts to 1/4 of what y would be if it were left alone. So 2/3 plus 1/4, they have a common denominator of 12. So we have 8/12 plus 3/12 equals 11/12. Drum y is 11/12 full. Answer choice C. Okay. On to the next page. Page 179. Question number 187. If x is, oh wait, I should put the answers in. I like to have the answers in first just so I can kind of not interrupt the flow of the description of what's going on, to pause and write things in. If there were an easy way to preload all of these without having, 15 to 20 separate image files, we would probably do that, but it's actually just easier to have me write them in and have you just pause and take deep breaths while I write in answer choices. Okay, so if x is greater than 0, x over 50 plus x over 25 is what percent of x? So x over 50 plus x over 25. So remember that percent equals, we'll use y because x is already being used, some number over 100. That's what percent means. It's a number per 100. The cent, the C-E-N-T in percent, it's related to our word century. It's from the Latin word for 100. So percent is just shorthand for saying out of 100. So we can just convert each of these two fractions into 100ths, and those will be the percents. So x over 50 is the same as 2x over 100, plus x over 25 is the same thing as 4x over 100. So that equals 6x over 100, or 6/100ths x, which is the same thing as 6% of x. Answer choice A. (179), number 188. So we have 4, 2, -4/3, -2, and -4. So if the operation symbol is defined for all a and b by the equation a symbol b equals a squared times b all over 3, then 2 symbol times the quantity 3 symbol -1 equals what? So the symbol appears twice, so we're going to need to do it 2 times. 1, 2. And we follow our order of operations. Parentheses come first, then exponents, multiplication, division, addition, and subtraction. Those don't really matter here, except for the parentheses. Parentheses come first. So the first one is going to be the value within the parentheses. We substitute a for, or 3 for a, and -1 for b. So the first operation then is 3 squared times our value for b over 3. It's always over 3. So 3 squared is 9 times -1 equals -9 divided by 3. So the whole thing equals -3. That value now represents b in our second time. So in this one, a equaled 3 and b equaled -1. In the second one, a equals 2 and b equals -3. So a squared gives us 2 squared times b, which is -3, all over 3. 2 squared is 4. 4 times -3 is -12. Denominator stays the same. -12/3 is the same thing as -4. Answer choice E. symbol questions, once you get over the mental block of just substituting values in, remembering that, what number you're using for A and B in each case, symbol questions can be among the easiest ones on the GMAT. They don't give them to you very often, but, and when they do, it would be great if you could say, yay, a symbol question, I love these because I always get them right. That would be great. Actually, that'd be great if you did that for every question, but no, there's no but. You can do that. All right, so 179, 189. 3, 4, 5, 6, 8. The inside dimensions of a rectangular wooden box are 6 inches by 8 inches by 10 inches. A cylindrical canister is to be placed inside the box so that it stands upright when the closed box rests on one of its 6 faces. Of all such canisters that could be used, what is the radius in inches of the one that has the maximum volume? Okay, so volume of a cylinder is the area of the circular end, pi r squared, and that whole thing is then multiplied times the height of the cylinder. That's actually how you compute the volume of a lot of regular solids. You find the area of the one face and then just multiply that times the distance that goes back. So we have a box. I shall draw it. It's not as important for this particular question, but visuals are still helpful. Okay, and we know that it has, we'll call that 10, we'll call this 6, and we'll call that 8. 10 by 6 by 8. And the top of the cylinder can be any one of these sides. The thing to remember here is that the cylinder, and so in general, because just to go back to the volume of the cylinder, we can suspect that because we're squaring the radius, that because 10, 6, and 8 are fairly close together, since we're squaring the radius, whatever cylinder has the largest radius is likely to be the one with the most volume, but that's not necessarily true. And with boxes of different sizes, that would definitely be untrue, and it would depend on the relative dimensions. But since these are relatively close together, we can suspect that. Anyway, back to the box. The thing to remember is that no matter which way you're putting a cylinder, so let's just pretend there's a circle there, and one here, and one here. So the cylinder can only be as wide as the narrowest side. So this one, the 10 by 6 side, the diameter can only be 6, which means the radius is going to be 3. That's a 3 in there. Oh, it looks like a 5, I'm sorry, but it's a 3. On the side that's 8 by 10, this one can only have the radius of 4, and the one that is 6 by 8, again, can only, it's supposed to be like that, but this one can also only have a radius of 3 because, the circle has the same distance from the center at all points, and so it's going to hit the shorter side first. You with me? So we just make a chart to make sure we get it right. So we have size of the base, we have the height, well, let's do the radius, the height, and then the volume. Hopefully that's enough room. So we just have 3 different cylinders here. We have, or 3 different bases. One is with the size 10 by 6 base. We have the 10 by 8 base and the 6 by 8 base. So the radius in this case is half the smaller one. That one's 3, this one's 4, this one's 3. The height is the side that isn't used, so 8, 6, and 10 respectively. The volume is pi r squared h, so this one is 3 times 3 squared, which is 9, times 8, which is 72, 72 pi. This one is 4 squared, which is 16, times 6, which gives us 96 pi. And then this one is 9 squared. Wait, did I do this right? Yeah. 9 squared times 10, it gives us 90 pi for the volume of that one. The one with the highest volume is the 10 by 8, and the question is, what is the radius of that one? Radius is 4. And so as we suspected, the one with the highest radius, because that value is squared times the height, that one did end up being the largest, but you can see that it was not the largest by much. 6 pi, in fact. Okay, I'm ready to move on. I hope you are too. 179, 190. Nine, 7, 5, 3, 1. What is the units digit of 13 to the 4th times 17 squared times 29 to the 3rd? 13 to the 4th. 17 squared. 29 to the 3rd. The units digit. So one of the things you may remember from long division, if you have, some number here times some number here, you end up with the units digit when you first multiply this times this. So that equals A. And then you have B, C, D, E. And then you replace zeros for each of the additional times that you're multiplying. So it's really only when you're multiplying the units digit times the units digit, that's what determines the units digit, because then you add them all up. A is always going to be at the bottom there. So imagine this is a long division problem with actual numbers. The units digit times the units digit is what gives you the answer, and that's true for any amount of multiplication, only the units times each other. So really we only have to care about the units digit of each of these. So 3 to the 4th is the same as 3 times 3 times 3 times 3, which is 9 times 9, which is 81. So the units digit is going to be 1 there. This one is 7 times 7, which is 49, so the units digit is going to be 9 here. And then 29 cubed, 9 times 9 times 9, 81 times 9. We really only have to worry about the units digit again. So this one is also going to be, 9, not plus, it's times, not plus. This one, the units digit is going to be 9 again. And actually it's 9 times 1 plus 9 times 80, so it equals 729, in case you were wondering what that is. Anyway, and then if we multiply each of these numbers together, 13 to the 4th times 17 squared times 29 cubed, we would be multiplying these units digits times each other. 1 times 9 times 9 equals 81, and once again then the units digit is going to be 1. Answer choice E. On to the second and final column of these pair of pages. Well, second on this page, fourth on this set of pages, page 179, question 191. So we have 6, 8, 10, 14, and 16. Pat will walk from intersection X to intersection Y along a route that is confined to the square grid of 4 streets and 3 avenues shown on the map above. How many routes from X to Y can Pat take that have the minimum possible length? I should probably draw the picture. So, and then we need 4, okay. Okay, So point X is down here. That's an X. Point Y is up here. So we have avenue A, B, C, and then streets 1, 2, 3, 4. Yeah, so this problem, well, I don't actually think there's a very easy way of doing this one. There's one way of doing it, and then there's a slightly easier way, or at least I found it mentally easier, so I'll show you the hard way first. The hard way, or harder way, is actually just to simply list every single way that the person, that Pat can go. So in order to go the minimum distance, basically Pat needs to move either up 1 or over 1 every step. So no backtracking, so no going down or to the left. So everything is either, you know, up or right. That brings Pat closer to point Y from point X. That eliminates a lot of, you know, crazy paths where Pat goes all over, you know, crosses every line twice or something like that. So we also know that it can't be more than 16. So here's where the answer choices also help us out. It can't be more than 16. So this is a case where the hard way then is actually just to list all of them. So you know, just starting from the bottom, Pat can go right, right, up, up, up. So right, right, up, 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 and then just start gradually eliminating different options. So we have right, up, right, up, up, right, up, up, right, up, and then right, up, 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 right. So we can see that in every case there's going to be 2 R's and 3 U's, which isn't surprising because there's, you know, more streets than there are avenues. Okay, so that exhausts actually the ones where Pat starts off going off to the right. So then we start the ones where Pat starts off going up, and there will be more of these because there's more, you know, streets going up. So we have up, right, right, up, 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 right, up, right, up, right, up, up, right, up, up, right, right, up, 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 right, up, right, and then the kind of the converse of the one going along the bottom edge, just going up, 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 right, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ways. So another way that after I did this the hard way, I realized afterwards that there's probably an easier way to do this. It's not a lot easier because you still have to list out all 10, but really another way to think about it is just imagine that you have something that has 5 slots, and you have to place 2 rights in there every possible way. So just ignore the whole up thing, so you don't really have to kind of keep track of it on the map. Just, you know, you can have, you know, 1, so these are our 5 slots. Haha, I can count 4, 5. So you just start listing just the rights. To my mind, it's actually a little bit easier to kind of track what we're doing here. So then we start off with, so that we did all the ones with right in the first position, then we start with right in the second position. So we start off with, you know, 2, 3, 2, 4, 4, 2, 5. You kind of get the idea. Doing it like this, I mean, that's actually still what's going on in what was over here, even down to the pattern. But doing it like this, to me, it's perhaps visually easier, and then you're only keeping track of 2 directions, because then by default, every blank in this grid is an up. So just something to keep in mind. This would have worked also with 3, you know, do the 3 ups in 5 different, you know, in the 5 different slots. But to me, it just seemed easier to just deal with the 2. So, you know, for future reference, save this mental image right here, because that could be a little bit easier if you get one of these, which you may not. Okay, let's do another one. 179, number 192. So 50, 200, 400, 625, and 800. The ratio by volume of soap to alcohol to water in a certain solution is 2 to 50 to 100. The solution will be altered so that the ratio of soap to alcohol is doubled, while the ratio of soap to water is halved. If the altered solution will contain 100 cubic centimeters of alcohol, how many cubic centimeters of water will it contain? Okay, so right now we have soap, alcohol, and water. And these are, it's a ratio. And that's 2 to 50 to 100. So the current soap to alcohol ratio is 2 to 50. The current soap to water ratio is 2 to 100. Okay, so the next thing we need to do then is double the soap to alcohol ratio. So we have, first step, double soap to alcohol. So 2/5, or, 2/50ths, I'm sorry. I don't know where I got 2/5 from. Okay. So doubling 2/50ths. So 2/50ths times 2 over 1 equals 4/50ths, which equals 2/25ths. Then we also need to have the soap to water ratio. So 2 over 100 times 1/2 equals, and you could have just said, well, half of 2 over 100 is 1 over 100. Anyway, that's what it equals, 1 over 100. So we can reconstitute our ratio here. For every 2, using this first one, for every 2 units of soap, we have 25 of alcohol. And for every 1 unit of soap, we have 100 of water. And so since this ratio starts off with 2 units of soap, we then know that there will be 200 water. So this is with the doubling the soap to alcohol and halving the soap to water. So the question is, of course, not asking us that. It's asking us how many cubic centimeters of water there will be in 100. Wait a minute, I lost track. Right, altered solution contains 100 cubic centimeters of alcohol. So to get this to 100, alcohol is the middle one, we have to multiply the whole thing times 4. So this will be 8 soap, 100 alcohol, which is what the problem actually says, and 800 water. The question is then, how many cubic centimeters of water will it contain? Well, we actually just solved for that. That's 800. Answer choice E. And I think I'm going to stop there just to make sure. We're not supposed to run over on these broadcasts because, you know, other programming can come right after it. And, you know, you're a busy person with lots of studying and work to do. So I'll stop there. Again, my name's Jim Jacobson. That's me up in the corner. You've been listening to Grockit's OGTV, which is, well, it depends on the test. This is the actual GMAT edition, where we're going through the 12th edition to the test, question by question, page by page, cover to cover, answers, explanations, strategies, little smiley faces occasionally, at least on my broadcast. Anyway, so next time we will pick up with question number 193, the last one on page 179. And I hope to see you there.